So how did it all begin? I mean, everything. The stars, the galaxies, you and me. It's the biggest question there is, right? For decades, scientists have been piecing together this incredible story of our cosmic origins, a story that's written in the light from the farthest reaches of space. And today, we're going to unpack that story, the Big Bang.
But first things first, let's clear up the biggest misconception right out of the gate. When you hear Big Bang, you probably picture this giant explosion, right? Like a bomb just going off in the middle of this big, empty black void. And hey, it's a powerful image, but it's not actually what happened.
And here's the key. This is the whole thing right here. The Big Bang was an explosion in space. It was the expansion of space itself. There wasn't a center for it to explode from, because every single point in the universe began rushing away from every other point, all at once. In fact, space and time, they were born in that very moment.
Okay, I know, that sounds like a pretty wild claim. So how can we be so sure about something that happened 13.8 billion years ago? Well, think of it this way. Cosmologists are like detectives at an ancient crime scene. They can't just rewind the tape, but they can piece together the clues that were left behind. And trust me, the clues are everywhere.
It really all boils down to three main lines of evidence. Each one of these is like a solid pillar holding up the whole theory, and when you put them all together, they paint this incredibly clear and consistent picture of how our universe began.
So clue number one came way back in the 1920s with Edwin Hubble. He looked through his telescope and noticed something amazing. Galaxies are flying away from us. But not just that. The farther away a galaxy is, the faster it's speeding away. The only way that makes sense is that the very fabric of space is stretching. And if you just run that film backwards, well, everything comes together into one single, incredibly hot, dense point. All right, clue number two is a total accident. Seriously. In 1964, a couple of radio astronomers kept picking up this faint, annoying hiss in their equipment. It was coming from every direction in the sky, and they couldn't get rid of it. Well, it turns out they had stumbled upon the afterglow of creation itself, the cosmic microwave background. It's literally the leftover heat from the Big Bang now cooled and stretched across the entire sky.
And this is where it gets really amazing. The precision is just staggering. The theory predicted what the temperature of this ancient light should be, and when we finally measured it, we found it's 2.725 Kelvin, just a couple degrees above absolute zero. It was a perfect match. I mean, this is one of the most successful predictions in the history of science, a total bullseye.
And that incredible predictive power doesn't stop with temperature. For our third and final clue, let's look at the universe's first ingredients. The Big Bang theory gives us a recipe. It lets us calculate exactly which elements should have been cooked up in those first few fiery minutes. The results are just stunning. The theory predicted that the early universe should be made of about 75% hydrogen and 25% helium, with just a tiny pinch of other light stuff. And guess what? When we look out at the most ancient gas clouds in the cosmos, that is exactly the recipe we find. Spot on.
Okay, so the evidence is solid. Now, let's build the timeline. We're going to rewind the clock all the way back to the beginning, to the most chaotic, most important moments in all of history. And the crazy part? All of this happened in less than a single second.
But before we dive in, there were a couple of big puzzles that had scientists scratching their heads. For one, why does the universe look so much the same in every direction? And why is its geometry so perfectly flat? The basic Big Bang model couldn't really explain this without some crazy fine-tuning. It needed one more piece to the puzzle.
And that missing piece was something called cosmic inflation. The idea is that in the very first sliver of a second, a tiny patch of space, smaller than an atom, just exploded in size. It underwent this incredible burst of hyperfast exponential growth. It stretched everything out so much that it ironed out all the wrinkles, making the universe perfectly flat and uniform, just like we see it today.
Okay, this timeline is just mind-boggling. I mean, look at these numbers. In the first flicker of existence, all the forces of nature were probably one single force. Then inflation kicks in and blows the universe up. A moment later, the Higgs field switches on, giving particles mass. And by just 1 microsecond, 1/1,000,000th of a second, a hot soup of quarks had cooled enough to stick together and form the first protons and neutrons. A whole cosmic history before the clock could even tick once. So after that absolute frenzy, the universe settled down for what you could call a long childhood. It was still incredibly hot, dense, and you couldn't see a thing. But a huge transformation was coming. One that would finally let the light shine free and set the stage for the cosmos we know today. For the first 380,000 years, the whole universe was like a thick, hot fog. Light particles, photons, were basically trapped, just bouncing around off a sea of free electrons like pinballs. But as the universe kept expanding and cooling, things finally calmed down enough for electrons to grab onto nuclei and formed first neutral atoms. And suddenly, just like that, the fog lifted. The universe became transparent, and all those trapped photons were set free. That liberated light, that's what we see today as the cosmic microwave background.
Once the fog cleared, the universe entered a period called the Dark Ages. There were no stars yet, no galaxies, just darkness. For millions of years, gravity was the only thing happening, slowly and patiently pulling gas into clumps around a scaffolding of dark matter. And then, at cosmic dawn, the very first massive stars roared to life. Their intense light blasted out, lighting up the cosmos for the very first time, and for good.
And that brings us more or less to the modern universe. The Big Bang Theory is, without a doubt, one of science's greatest triumphs. But what's so cool is that the story isn't over, not by a long shot. In fact, by figuring out our past, we've uncovered some of the deepest, most profound mysteries you could possibly imagine.
Just take a look at this. It's a census of everything in the universe. And what you see is that everything we know, every star, every planet, every person, all of it makes up only about 5% of reality. Just 5%. The rest is made of two things we know almost nothing about: dark matter, which is about 27%, and dark energy, which makes up a staggering 68%. We live in a universe where 95% of it is a complete mystery. And that leads us to the biggest questions out there, the cosmic frontier. We have no idea what dark matter or dark energy really are. We're still puzzled about how gigantic black holes grew so big, so fast in the early universe. And of course, there's the ultimate question that still hangs over everything. What happened before the beginning? What came before the Big Bang?
You know, the story of the Big Bang is our story. It's the story of how we got here, from this unimaginable beginning to a cosmos filled with so much wonder. But it's also a story that reminds us just how much is left to discover. The universe has given up so many of its secrets, but you have to wonder, what else is still out there, hiding in the dark?